GCSE aspirants, Earth Sun relations, conditions on equinoxes and solstices. Here is the table. For all regions in the northern hemisphere up to the latitude of the Arctic Circle, following the shortest day of the year in the December solstice, the period of daylight gradually increases, reaching 12 hours of daylight on the March equinox. After the equinox, day length continues to increase until the longest day of the year on the June solstice. During this period, day length is diminishing in the southern hemisphere. Following the longest day of the year in the northern hemisphere, on the June solstice, the pattern is reversed, with the days getting shorter in the northern hemisphere, reaching 12 hours on the September equinox and then diminishing until the shortest day of the year on the December solstice. During this period, the length is increasing in the southern hemisphere. Day length in the Arctic and Antarctic. The patterns of day and night in the Arctic and Antarctic deserves special mention. For an observer at the North Pole, the sun rises on the March equinox and is above the horizon continuously for the next 6 months, circling the horizon higher and higher each day until the June solstice, after which it circles lower and lower until setting on the September equinox. Week by week after the March equinox, the region experiencing 24 hours of daylight extends south from the North Pole until the June solstice. When an entire region from the northern pole to the Arctic Circle experiences 24 hours of daylight following the June solstice, the region in the Arctic experiencing 24 hours of daylight diminishes week by week until the September equinox, when the sun sets at the North Pole and remains below the horizon continuously for the next 6 months. Week by week following the September equinox, the region experiencing 24 hours of darkness extend from south from the North Pole until the December solstice, when the entire region from the North Pole to the Arctic Circle experiences 24 hours of darkness. Following the December solstice, the region experiences 24 hours of darkness, diminishes week by week until the March equinox, when the sun again rises at the North Pole. Here is the diagram you can see. In the Antarctic region of the southern hemisphere, these seasonal patterns are simply reversed. Significance of seasonal patterns, both day and length and the angle at which the sun's rays strike Earth are principal determinants of the amount of solar energy received at any particular latitude. As a generalization, the higher the angle at which the sunlight strikes Earth, the more effective is the resultant heating. Where the vertical rays of the sun strike Earth, solar energy is concentrated onto the smallest possible surface area. Where the sun's rays strike Earth at smaller angles, the same amount of energy is spread over a larger surface area. Thus, the amount of energy reaching a particular surface area is significantly